greatest integer function, let y is equal to square bracket of x. This square bracket of x indicates the integral part of x, which is the nearest and smaller integer to x. It is also known as the floor of x. Let x is equal to I plus f, where I is the integral part. I is the integral part and f is the fractional part. This is fractional part. Okay. So here this fractional part f lies between 0 and 1. That is 0 less than or equal to f less than 1. So as for example, we consider there are two integers, consecutive integers, respectively I and I plus 1. So this is number line, and on this number line there are 2 points, I and I plus 1. So if a value lies between these two consecutive integers, say x, then its integral part, that is the greatest integer part, will be I. So again I repeat, what is square bracket of x? Sometimes we say that it is box of x. So square bracket of x indicates the integral part of x, which is the nearest and smaller integer to x. It is also known as the floor of x. If x is equal to say 1.5, so what will be the integral part of x? This is 1. Why? See that 1.5 lies between 1 and 2. This is 1.5. So its integral part is 1. So greatest integer part of x is equal to 1.5 is 1. Okay. Similarly, we take another value. Say x is equal to minus 1.5. Now minus 1.5 lies between, say this is 0, this is minus 1, and this one is minus 2. So minus 1.5 lies here. This is minus 1.5. So its integral part is minus 2. So square bracket of x, or the floor of x, is equal to minus 2. So now friends, we shall find out the graph of this function. Y is equal to the greatest integer part of x, or the square bracket of x, is equal to 0 if 0 less than or equal to x less than 1. This may be 1 if 1 less than or equal to x less than 2. This square bracket of x may be 2 if 2 less than or equal to x less than 3, and in this way it is going on. The value of the square bracket of x may be negative 1 if minus 1 less than or equal to x less than 0. This may be minus 2 if minus 2 less than or equal to x less than minus 1. So now we shall draw the graph of this function. Say this is x-axis and this one is y-axis. This is origin. Say this is 1, 2, 3 and so on. Minus 1, minus 2 and so on. Here also on this y-axis 1, 2, 3 and so on. On the negative side also minus 1, minus 2, minus 3 and so on. So friends, you see that the greatest integer part of x is equal to 0 if 0 less than or equal to x less than 1. That means from 0 to 1 the value of y will be 0. So we can take from 0 to 1. So from 0 to 1, we change the pen. Yes, like this. From 0 to 1, the value of the function is equal to 0. Now from 1 to 2, that means from 1 to 2, the value of the function y is equal to 1. So 1 unit above. So this is like this. From 2 to 3, that means from 2 to 3, the value of this function y is equal to 2. So 2 units above. This is 2. Again on the negative side also, from minus 1 to 0, minus 1 to 0, this is minus 1. So 1 unit below the x-axis. Yes. And from minus 2 to minus 1, minus 2 to minus 1, the value of this function is minus 2. So we have to start from this point. So I join these points. These are the dotted lines. This height is 2 units. This height is 1 unit. This height is also 1 unit in the negative direction. And this is the height is here also 2 units on the negative direction of y-axis. So friends, this is actually the graph of the greatest integer function. Next we shall study on the fractional part of a function. Fractional part function. Let y is equal to curly bracket x. It indicates the fractional part of x. Let x is equal to I plus f, where I is the integral part and f is the fractional part. So greatest part of x, that is the integral part of x, is equal to I, and the fractional part of x is only f. Friends, this y now can be written as fractional part of x is equal to x minus the integral part of x. So friend, this is x minus 0 if x lies between 0 and 1. This may be written x minus 1 if 1 less than or equal to x less than 2. This can be written x minus 2 if 2 less than or equal to x less than 3, etc. Okay. Now I shall draw the graph of this fractional part function. Let us consider that this is the x-axis, this one the y-axis. So this is the origin. Say this is 0, 1. Okay. So through these point 0, 1, this line is actually y is equal to 1. This line is y is equal to 1. Now friends, see that if I take some points on these x-axis, say this is 1, 0, this is 2, 0, this one is say 3, 0. I am writing just 1, 2, 3 like this. Actually this is 1, 0, this is 2, 0, this is 3, 0. On the left side also you can write minus 1, 0. I am writing just minus 1. And now see that this y is equal to x if 0 less than or equal to x less than 1. That means from this point 0 to 1, the value of y, that is the fractional part of this function, is equal to x. So I have to write this like this. Yes. From 0 to 1, this is the function y is equal to x. Y is equal to x is a line which makes 45 degree with the positive direction of x-axis. So this angle is equal to 45 degree. Now y is equal to x minus 1 if 1 less than or equal to x less than 2. That means when x lies between 1 and 2, that is from 1 and 2, the function y is equal to x minus 1. This is also another line which will pass through 1 and with the slope 45 degree with the positive direction of x-axis. So the line will be like this. And when x lies between 2 and 3, that means from 2 to 3, the function y is equal to x minus 2. So it will pass through 2, and the slope is 45 degree. Yes, this is 45 degree, and the slope is 1. Sorry, the slope is 1. Here also 1, 1, and it makes 45 degree with the opposite direction of x-axis. In this way, on the negative side also, you can draw some lines. Yes, like this. So it is going on and continuing. This is actually the fractional part function graph. Thank you.